Okay, so in this video we're going to start looking at functions and how to evaluate functions. So I'll just jump right into an example. Let f of x equals 3x squared plus x minus 5, and we want to evaluate for all of these different values of x. So if you're just evaluating at a number, f of negative 2, all we are doing is plugging that number in and simplifying. So that's going to be negative 2 squared would be 4 times 3 would be 12 minus 2 minus 5, which is going to be 5. F of 0. When evaluating a polynomial, plugging in 0 is nice because all your x terms will go away and you will just end up with the constant term negative 5. F of 4. 3 times 4 squared plus 4 minus 5, which is 16 times 3, which is 48, plus 4 minus 5, that's going to be 47. And then f of 1/2, evaluating a fraction, same thing, we're just going to plug it in. We just need to make sure that we can work with fractions. So 1/2 squared is 1/4 times 3 would be 3/4 plus a half minus 5. I'm going to get a common denominator here, so this is going to be 3/4 plus 2/4, and I'm going to go ahead and make this minus 20/4. Right? 5 is 20/4. So we have negative 15/4. Next example, we're going to look at plugging in essentially values for x that we do not know their numerical value. So f of a, all that means is I want to plug in a for x, but I can't evaluate because I don't know what a is. So that's just going to be 2a squared plus 3a minus 1, and that's all I can do. F of a plus h, this means we're going to replace all of our x's with a plus h. So I'm going to do 2 times a plus h squared plus 3 times a plus h minus 1. The mistake that people make here is the a plus h squared part. Recall that squaring something means multiplying it by itself. So this means I have a plus h times a plus h there. I'm going to go ahead and distribute the 3. So I've got plus 3a plus 3h minus 1. And I need to multiply these binomials out. Okay, so that's actually going to give me, if I do that, that's going to give me a squared plus 2ah plus h squared. And we have plus 3a plus 3h minus 1. And then I'm going to distribute my 2. So that's going to give me 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. And that is f of a plus h. So I plugged in a plus h for all of my x's and multiplied all that out. So this next part is something that is actually an application that we're going to need to know later on when we get into some calculus. And it's called a difference quotient. F of a plus h minus f of a all over h. And we're going to simplify this. Now we already have the top part of this. We already have f of a plus h, and we already have f of a. So I am going to, for this f of a plus h part, that's what we just did here. So I've got 2a squared plus 4ah plus 2h squared plus 3a plus 3h minus 1. Then we have minus f of a. So then I'm going to do minus, and I'm going to plug in f of a, which is 2a squared plus 3a minus 1. And that is all divided by h. Now, You want to make sure that you subtract the entire f of a. That's why I put it in parentheses here, because I need to make sure that this subtraction gets to all of those terms. And what's going to happen then is I've got 2a squared minus 2a squared, and I have 3a minus 3a, and I have negative 1 minus negative 1, or plus 1, and all those will cancel out. And that's going to leave us with 4ah plus 2h squared plus 3h, all divided by h. And at that point, everything has an h on top, so I can cancel an h with everything on top with the h on the bottom, and that gives us 4a plus 2h plus 3. Okay, next up is what's called a piecewise defined function. We're going to get more into the graph of this in a later video. But a piecewise function says that I have a function, but I've got two different ways that my function, or more, two different ways that my function is being defined. Okay, there could be more than two. And it's basically saying that your function is just going to be this top thing as long as your x's are in this range, or it's going to be this bottom thing if your x is in this range. So when you're evaluating a piecewise function, you just have to think about where the x is in relationship to what you're looking at on the right, and then that's going to determine which part of this you plug it into. So what we have here is a cell phone plan. It's $80 a month. That includes 5 gigs of data for free, but then if you go over the 5 gigs, it will charge $15 for each additional gig. Alright, so what this piecewise defined function says is that if your x is between 0 and 5, where x is the additional, x is the number of gigabytes that you use, if we use between 0 and 5, the cost is $80. Right? There's nothing there. So if I go down here to A, if I want to evaluate what is essentially C of 3, I want to know what happens when we use 3 gigs. Well, because 3 falls in this range of x's, that means I just get 80. Okay, I'm going to use that top function and that top piece of that function, and that just gives me 80. If we are doing 5 gigabytes of data, again, 5 falls into this first part. You do need to be a little bit careful here. It's because we have the or equal to 5 with this first one, and we do not have the or equal to 5 with this second inequality. Okay, so if I'm actually plugging in 5, I'm again going to use this top one because I get 5 gigs of free data. So C of 5 is going to be 80 as well. So the cost if we just use 3 gigabytes, $80. The cost if we use 5 gigabytes, $80. And now on part C, I'm using 7 gigabytes of data. 7 is greater than 5, so it fits the criteria here on the bottom part, which means I need to plug in 7 into this piece that's across from that. So C of 7 is going to be 80 plus 15 times 7 minus 5. And if you think about it, what we're really doing here is we're doing $15 for every gigabyte over 5, which is going to be 2 of them. And so that's going to be 30 plus 80, which is going to be $110. So if we use 7 gigabytes of data, it's going to cost us $110. Okay, so that is how you evaluate a piecewise function. Again, we'll get more into a graph of that. But hopefully evaluating functions in its entirety is not all that challenging, and you are essentially just plugging in a number into in for x and evaluating.